Part 3, page 153, we're picking up on the action here of what is this original layer of the epidermis. And the main cells here are keratinocytes. These are the ones that are reproducing quickly and producing daughter cells. We noted that the first daughter cells are held apart from each other by desmosomes, and we have the little, how shall I say, little spines right there. And of course that's why we're calling them Stratum Spinosum. Okay. We do have percolating up through here, we have melanin from our melanocytes. Here they're showing us this sort of continuous nature of melanin, but if you look under a real, let's see if I can see it over here. We should, no, I can't really see it. If you get a lot of light in your microscope going on, and you get a lighter hue here, you can actually see the color. You can see the brownish sort of yellow color of melanin, and you can see how the little individual particles percolate up, especially if you have, if you're working with the skin of a black person, then you're going to be having a clearer visual of melanin. So if this is somebody who is a white folk and they, you know, haven't spent much time out in the sun, you're not going to see a lot going on there. So at any rate, coming back here to the artistic rendition, we do have our, as indicated here, this is a dendritic cell. It's got these long little things that stick out, and it's attempting to eat any sort of particulate matter. Here's our neuron with the Merkel cell. This is for fine touch right there. We'll get into that at some point. And then as we percolate up higher, we get to this next layer up here called the Stratum Granulosum. So the Stratum Granulosum is where it's still sort of a prickly cell looking situation here, right? So the Stratum Spinosum moving on up to the Stratum Granulosum. So we still have sort of like these little spines, but now there's a shift in terms of the contents of the cell. Here we're actually creating a certain kind of protein that they're identifying here. And the granulosum, it says typically 5 layers of flattened cells. We're having special kinds of keratohyalin granules. Okay, so we're making that protein, that special protein. Then we go up into the next layer, and now we're into that death of the cell situation, where the cell has now lost its nucleus, it's lost its actual sort of functioning format, and the keratin is present there. A lot of the organelles are kind of missing. These are flat little units. The membrane is pressed down. So, and here we have quite the layer of callus going on here. Okay, so this could be the palm of the hand, it could be the sole of the foot someplace where there is a significant callus, and so we have this huge layer going on. Okay, and this is, it's called the Stratum Corneum. Okay, so out here, do you see the difference between the spinosum and out here the change in stain actually indicates that something else is going on with the protein. So we have our keratohyalin, and then finally out here there's really no nucleus or anything at all. This is just a continuous sort of mashing together of dead cells all the way out to here. Okay, interesting that when we see each other, one another, or we look in the mirror, we're mostly just seeing dead cells. So that's the idea here. Moving on, we get to this sort of next visual. And so here's what I need you to know from this. Here they've actually provided you with something sort of clear in the way of a callus. Right, isn't that an interesting looking callus there? This is the whole epidermis from the basal layer to the layer that is the spinosum, the corneosum, and rather the let's recall that particular granulosa, excuse me. So spinosum, granulosa, and then corneum. So we have all of those layers impacted here. This is the corneum out here, and in this case, it's actually quite clear, right? We have a callus out here. Down and through here, we see capillary networks in through there, more stringently represented over here, and then we see the dermis. So this is the reticular layer. This is dense, irregular connective tissue in which the, how shall I say, the fibroblasts have woven the fabric of collagen. So it's a three-dimensional weaving, and it provides this nice supportive textile, really thick textile, for the epidermis above. Okay, so that's that program. Then we take a look at how cleavage exists in the human body. For those of you that near your way toward the surgeon, surgeons generally, when there's a lot of laparoscopic surgery these days, so some of this doesn't hold quite the same way as it once did. But historically, when we're using the scalpel and we're making openings with the scalpel and we're not using laparoscopic surgery, then we're attempting to follow the lines of cleavage here. Also, this is something that's useful for you to know. If you practice acupuncture, you can slip a needle in pretty well by following these lines of cleavage and causing very little in the way of pain to your patient. And I would submit to you that a lot of you who are becoming nurses will be also well advised. I'm a little bit put off by the idea of a perpendicular stabbing of the, how shall I say, the syringe. And it is possible to angle. I give shots sometimes to people. I'm not supposed to because I'm not really a nurse or a doctor at this point in my life, but I do help out some friends of mine who are transgender and they need to take shots for a variety of reasons. But anyways, I give shots right here and I angle the syringe. And on many occasions, I'm already done delivering what I'm supposed to deliver with the syringe. And they said, when are you going to do it? And I say, I'm already done. So they don't feel it so much. I have good days and bad days, and you'll see how that works for yourself. But nevertheless, we have these lines of cleavage that really kind of matter. Okay, moving on, we also have flexure lines, of course. We have flexure lines here between the portions of the finger at the joint, flexure lines across the palm of the hand. And then we get these little detailed things here, which can actually be used to identify individuals. These are the frictional ridges of the fingertip that provide us with, how shall I say, information about the individual, which is unique to the individual, so fingerprints. So the idea here is that we can actually grasp things. One of the reasons they say that our skin gets all wrinkly when we've been in the bathtub too long is that actually improves the ability of the frictional ridges to grab things. So you can have a wet hand. As long as it's not soapy, it's just wet, then you can actually still grab things because of the wrinkling of the fingers. Okay, so then let's stop here.